Right, so we begin our proof chapter. There's going to be a couple lessons out of chapter 2 and a couple out of chapter 3, and I kind of smush them together and make their own unit out of them. So we're going to go through, we're going to do a lot of different kinds of proofs and get you started with this. Okay, so the first thing I need to go through, you notice on your notes that you've got a whole stack of just properties, one right after another. These are properties that you've seen before. I know Mrs. Burke teaches them in junior high. I know Mrs. Orasek taught them last year. So we're just going to go through these quickly. You can pause as needed. Okay, first one, addition property. I put the if-then statement for this first. But this is just basically if you add the same thing, add something to one side of the equation, you have to add it to the other. That's the addition property of equality. Then you have the subtraction property of equality. It's basically the same thing as addition, but it's subtracting a number. Multiplication property, same deal. If you multiply something to one side, you have to multiply to the other side. Division property takes a little bit different form, because you cannot divide by 0. So you divide both sides by the same number, but you can't divide by 0. Then we get into some properties that are specific to geometry. The reflexive property, A equals A, you'll get something down at the bottom of your equation like x equals x or 3 equals 3. That's the reflexive property. We'll use this in proofs to name a specific side of a triangle that's shared between two triangles. And so it'll say like AB is congruent to AB. That's a reflexive property. The symmetric property. It says here, if A equals B, then B equals A. Picture you're solving an equation and at the bottom you get 2 equals x. This is the property that allows you to flip that around and make that x equals 2. Okay, that's symmetric property. Then you have the transitive property. If A equals B and B equals C, then A has to equal C. Substitution property. We've talked about this before when we solve linear equations. We can substitute something in for something else. So if A equals B, then B can replace A in any expression, and A can replace B in any expression. Then you have the distributive property. You guys are pretty good at this. You distribute whatever is in front of the parentheses. So like down here, we distribute, we get 2x squared plus 6x. Kind of a popular property for everybody to use. All right, so let's try one. This is an angle addition postulate kind of problem. We're going to justify each step. So for me, I draw a T-chart. I put my work on the left side and I put my reasons on the right. Okay, so first step, we need to add these two angles together. They give us the angle AOC. That whole angle there is 139 degrees. That's over here in the given. So we need to add the angles together. So in geometry, we always put the geometry step first, if possible. Okay, so I know that if I add the little angle AOB, plus angle BOC equals angle AOC. This is angle addition postulate, because that's what it tells us. We add two angles together, we get a bigger angle. All right. Our next step is to put what each of these angles are. So angle AOB in the picture is x. Angle BOC in the picture is 2x plus 10. And then angle AOC in the picture is 139 because they gave it to us. This is called substitution because we replaced things with what they are or what they're equal to. All right, from here we just have to solve. So I look at this and I say, well, I need to combine like terms. Okay, so we combine like terms and you can put CLT, combine like terms. Then I need to get x by itself, so I'm going to subtract 10 from both sides. So that makes this that, because I subtracted 10. My reason, subtraction property. Now I just need to get x by itself, so I'm going to divide by 3. So that would be 43 over here would be division property. That's a proof. That's an algebraic proof, actually. But that's what you're going to be working on. All right, let's do this one. They tell you that AC is 21. So sometimes you have to have the givens to figure out what you're going to do. So first thing we need to do is show the segment addition step to show that those two segments add together. So we're going to take AB plus BC equals AC. And that's segment addition postulate. Then we do, just like we did last time, we have to replace them with what they are in the picture. So AB is 2y, BC is 3y minus 9, and AC they gave us was 21, so we substituted. You notice your reasons are basically just what you did. All right, now we look at our equation. We need to combine like terms. So we're going to combine like terms. Then we need to get y by itself, so we're going to add 9 to both sides. When I do that, I get 30 over here. So that was addition property. And now I need to get y completely by itself, so I'm going to divide by 5. And that's division property. Okay, it's no different than what you did in junior high. Maybe a little less strict because I want you to get the concept of it. But you've already done it before, so that's okay. All right, so now here is a proof. I've worked it for you. I want you to fill in the reasons, okay? They gave you that LM bisects angle KLN, okay? So they drew all that in there. That's given. Sometimes we have to put a step that says given. So then the next step I did was the definition of an angle bisector. If LM is a bisector, that means those two angles have to be equal, okay? So we went from this, now all of a sudden we have x's and numbers. That has to be a substitution step because we replaced the angles with what they are in the picture. Now you have to look at it and figure out what you did to solve it. They got all the x's on one side, so they would have to subtract 2x to do that. This one was by subtraction property. And then to get x completely by itself, they would have to divide. Okay, this is good practice to see what you need to put in as your reasons. All right, one last one. We're going to name the property for each of these. So the first one, it says angle K is congruent to angle K. That is reflexive property. The next one, it says if 2x minus 8 equals 10, then 2x equals 18. Using your solving steps, you would see that you have to add 8 to both sides to make this happen. So that's the addition property of equality. For this one, it says if RS is congruent to TW and TW is congruent to PQ, then RS is congruent to PQ. That is transitive property. You'll use that one quite a bit. You could also call it substitution because you can replace one with another, but it's textbook transitive property. Then the last one, if measure of angle A is equal to the measure of angle B, then measure of angle B is equal to the measure of angle A. That is symmetric property. Okay, we're going to practice a lot with these just to make sure that we've got them.